The Chernobyl Nuclear Power Plant. A Chernobyl Nuclear Power Station is a nuclear power station under decommissioning near the city of Pripyat, Ukraine, 14.5 kilometers northwest of the city of Chernobyl, 16 kilometers from the Belarus-Ukraine border, and about 110 kilometers north of Kiev. Reactor No.4 was the site of the Chernobyl disaster in 1986, and the power plant is now within a large restricted area known as the Chernobyl Exclusion Zone. Both the zone and the former power plant are administered by the state agency in Administration of Exclusion Zone. The nuclear power plant site is to be cleaned by 2065. On January 3, 2010, a Ukrainian law stipulating a program toward this objective came into effect. Construction. The V.I. Lenin Nuclear Power Station, as it was known during the Soviet times, consisted of 4 reactors of type RBMK-1000, each capable of producing 1,000 megawatts of electric power, and the 4 together produced about 10% of Ukraine's electricity at the time of the accident. The Chernobyl station is 18 kilometers northwest of the city of Chernobyl, 16 kilometers from the border of Ukraine and Belarus, and about 100 kilometers north of Kiev. Construction of the plant and the nearby city of Pripyat, Ukraine, to house workers and the families began in 1970, with Reactor No.1 commissioned in 1977. It was the third nuclear power station in the Soviet Union of the RBMK type, and the first ever nuclear power plant on Ukrainian soil. The completion of the first reactor in 1977 was followed by Reactor No.2, No.3, and No.4. 2 more blocks, numbered 5 and 6, of more or less the same reactor design, were planned at a site roughly a kilometer's distance from the contiguous buildings of the 4 older blocks. Reactor No.5 was about 70% complete at the time of the accident in Block 4 and was scheduled to start operating in the 7th of November 1986. In the aftermath of the accident, works were halted, and eventually cancelled in April 1989, just days before the 3rd anniversary of the 1986 explosion. Reactor No.3 and 4 were second-generation units, whereas No.1 and 2 were first-generation units. Second-generation RBMK designs were fitted with a more secure containment structure visible in photos of the facility. Electrical systems. The power plant is connected to the 330 kV and 750 kV electrical grid. The block has 2 electrical generators connected to the 750 kV grid by a single generator transformer. The generators are connected to the common transformer by 2 switches in series. Between them, the unit transformers are connected to supply power to the power plant's own systems. Each generator can therefore be connected to the unit transformer to power the plant, or to the unit transformer and the generator transformer to also feed power to the grid. The 330 kV line is normally not used, and serves as an external power supply, connected to a station S transformer, meaning to the power plant's electrical systems. The plant is powered by its own generators, or at an event gets power from the 750 kV national grid through the main grid backup feed-in transformer, or from the 330 kV level feed-in grid transformer 2, or from the other power plant blocks via 2 reserve bus bars. In case of total external power loss, the essential systems can be powered by diesel generators. Each unit S transformer is therefore connected to 2 6 kV main power line switchboards A and B. powering principal essential systems and connected to even another transformers at voltage 4 kV, which is backed up twice. The 7A, 7B, and 8B boards are also connected to the three essential power lines, each also having its own diesel generator. In case of a coolant circuit failure with simultaneous loss of external power, the essential power can be supplied by the spinning down turbo generators for about 45 to 50 seconds, during which time the diesel generators should start up. The generators have started automatically within 15 seconds at loss of off-site power. Turbo generators. The electrical energy is generated by a pair of 500 MW hydrogen-cooled turbo generators. These are located in the 600 meters long machine hall, adjacent to the reactor building. The turbines, the venerable 5-cylinder K500-65 3000 are supplied by the Kharkiv turbine plant, the electrical generators of the TBB 500. The turbine and the generator rotors are mounted on the same shaft. The combined weight of the rotors is almost 200 T and the nominal rotational speed is 3000 revolutions per minute. The turbo generator is 39 meters long and its total weight is 1200 T. The coolant flow for each turbine is 82,880 T per hour. The generator produces 20 kV 50 Hz AC power. The generator's stator is cooled by water while its rotor is cooled by hydrogen. The hydrogen for the generators is manufactured on-site by electrolysis. The design and reliability of the turbines earned them the State Prize of Ukraine for 1979. The Kharkiv turbine plant later developed a new version of the turbine, K500-65 3000-2, in an attempt to reduce use of valuable metal. The Chernobyl plant was equipped with both types of turbines. Block 4 had the newer ones. The newer turbines, however, turned out to be more sensitive to their operating parameters, and the bearings had frequent problems with vibrations. Reactor fleet. 4 RBMK reactors were at Chernobyl NPP. Reactors number 1 to 3 continued to operate until the shutdown in the 1990s. Number 5 and number 6 were cancelled while partially complete. Accidents. 1986, Reactor number 4 disaster. On Saturday, April 26, 1986, a disaster occurred at Reactor No.4, which has been widely regarded as the worst accident in the history of nuclear power in the world. As a result, Reactor No.4 was completely destroyed and is being enclosed in a concrete and lead sarcophagus to prevent further escape of radioactivity. Large areas of Europe were affected by the accident. The radioactive cloud spread as far away as Norway. 1991, Reactor No.2 fire. The Chernobyl nuclear plant utilized one large open turbine hall for all 4 reactors without any separating walls. Each reactor had 2 turbines. On October 11, 1991, a fire broke out in the turbine hall of reactor number 2. The fire began in Reactor No.2's turbine 4 while the turbine was being idled for repairs. A faulty switch caused a surge of current to the turbine, igniting insulating material on some electrical wiring. This subsequently led to hydrogen, used as a turbine coolant, being leaked into the turbine hall, which apparently created the conditions for fire to start in the roof and for one of the trusses supporting the roof to collapse. The adjacent reactor hall and reactor were unaffected. Ukraine's 1991 independence from the Soviet Union generated further discussion on the Chernobyl topic, because the Rada, Ukraine's new parliament, was composed largely of young reformers. Discussions about the future of nuclear energy in Ukraine helped move the government toward the political decision to cancel the operation of Reactor No.2. 2013 collapse. On February 13, 2013, a 600-square-meter portion of the roof and wall adjacent to the covered part of the turbine hall collapsed into the entombed area of the turbine hall. The collapse did not affect any other part of the object shelter. The new safe confinement. No variances in radiation levels as a result of the incident were detected. The roof which collapsed was built after the Chernobyl disaster. Plant shut down and decommissioning. After the explosion at Reactor No. 4, the remaining 3 reactors at the power plant continued to operate. In 1991, Reactor No. 2 caught fire and was subsequently shut down. In November 1996, Reactor No. 1 was shut down, followed by Reactor No. 3 in 2000. The schedule for plant decommissioning is intimately wrapped with the dismantling of Reactor No. 4 and the decontamination of its environs. The Chernobyl new safe confinement will have equipment which will make decommissioning relatively incidental to, yet an integral part of, the cleanup of the exploded reactor. Removal of uncontaminated equipment has begun at Reactor No. 1 and this work could be complete by 2020 to 2022. On April 9, 2015, Units 1 to 3 entered the decommissioning phase. The isotope responsible for the majority of the external gamma radiation dose at the site is cesium-137, which has a half-life of about 30 years. As of 2016, the radiation exposure from that radionuclide has declined by half since the 1986 accident. Sarcophagus replacement originally announced in June 2003. A new steel containment structure named the New Safe Confinement would be built to replace the aging and hastily built sarcophagus that currently protects Reactor No. 4. Though the project's development has been delayed several times, construction officially began in September 2010. The new safe confinement is financed by an international fund managed by the European Bank for Reconstruction and Development, is being designed and built by the French-led consortium Novaca, which includes the companies Bouygues and Vinci. Novaca is building a giant arch-shaped structure out of steel, 190 meters wide and 200 meters long to cover the old crumbling concrete dome that is currently in use. This steel casing project is expected to cost $1.4 billion, and expected to be completed by the end of 2016. A separate deal has been made with the American firm Holtec to build a storage facility within the exclusion zone for nuclear waste produced by Chernobyl. The shelter replacement required demolition of the recognizable 75-meter-tall exhaust chimney which was used for both reactors No. 3 and 4. A shorter stack has been constructed adjacent to it that will be used to ventilate the new shelter. General Directors, 1970 to 1986 Viktor Bryakhanov, 1986-1987 Eric Pozdyshev, 1987 to 1992 Mikhailo Umanets, 1994 to 1998 Serhiy Parashin, 2004-2005 Alexander Smyshlyayev, 2005 Present Igor Gramotkin.